Hi everyone, today we are going to learn 10.4 constant coefficient homogeneous system. This will be last section. Yay! Okay, so we have, look, y prime, and then we have a little notation here, right? So this is a vector notation. So y prime equal to a, and there's another vector notation, right? So we are using vector notation this way, or the bold, right? Or these two arrows at the end, or just one arrow, right? So I am preferring using the only one arrow, one side, because it's more easier to one step, yeah? Okay, so we have a theta. The A, what we have earlier, that is matrix. So we have a constant matrix has real eigenvalues. So we talk about the eigenvalues, eigenvectors in linear algebra course, right? So we are using for eigenvalues, eigenvectors. So in that case, eigenvalues need not to be distinct. That means not distinct means they can be repeated. Yeah. So with, they say that associated linearly independent, then if we have a trivial solution, all the element equal to 0, right? And we have a linearly independent eigenvectors, x sub 1, x sub 2, x sub n, and the functions. We have y sub 1 equal to x sub 1 into the eigenvalues of t, right? So this, everything x sub 1, x sub 2, x sub n, these eigenvectors. And then we have eigenvalues. Sorry, eigenvalues, correct, right? I did not mix up the values and then eigenvectors, right? Okay, so it's the form of fundamental set of solutions. So we have, like earlier, the form y prime with a vector equal to the constant matrix A times with another vector, right? Okay, so we have, this is a general solution. Normally we have a general solution. The form is y equal to y sub 1 and c sub 1, right? Y sub 1 plus c sub 2, y sub 2. Yeah, keep going, right? So I want to mention that c sub n, y sub n, right? Okay, now, since we have a vector y sub 1, and everything will be changed to a vector, right? So that will be vector form, and this is a vector, this is a vector, this is a vector, right? Then the vector y sub 1, we have this form, right? So this one we have here, and then c sub 2, vector y sub 2 is x sub 2 e to the y sub 2, yeah? And then y sub n over vector, the form has x sub n, and so basically eigenvectors we get with the eigenvalues of e to the t, right? So we are using here, yeah? Okay, let us do questions here. Example, so find the general solution, yeah? So there will be y equal to c sub 1, y sub 1 with the vectors, right? Plus c sub 2, y sub 2. In that case, then what is the y sub 1? That, right? Y sub 2, that. Make sense? Okay, so let us do this one. Okay, first of all, we want to find eigenvalues first. Then we are using eigenvalues, then we find the eigenvectors, right? So let us do that. So A. So for eigenvalues, lambda, right? We call the lambda, right? So we can use the determinant of lambda I minus A equal to 0, or we can use another form, right? So determinant of A minus lambda I equal to 0, okay? So let us using this one. So that will be determinant of and lambda, and I means 1 0 0 1 for 2 by 2 matrix, and minus A in the case we have 2 4 4 2, right? So 2 4 oof 2 4 4 2 equal to 0, right? So let me rewrite. This one is I and this is A, right? Okay, so let's solve that eigenvalue lambda, right? Okay, so there will be determinant of, and we multiply with the lambda. So there will be lambda 0 0 lambda minus 2 4 4 2 equal to 0, right? Okay, so there will be determinant of, we have a lambda minus 2, and don't forget this one, right? 0 minus 4, right? So it's a negative 4, and then this one also 0 minus 4, so negative 4. Ooh. And then the last one is lambda minus 2 equal to 0. Yeah, make sense? Okay, so it's a 2 by 2 determinant, so we can multiply this way, right? All right, so we have that. So that will be lambda minus 2 squared minus negative is positive. This is 16 then, right? 16 equal to 0. Okay, then we can recognize the formula, which is a squared minus b squared, that is a minus b, a plus b, right? Okay, so that will be a, this is b, right? So that will be, no, this is square, better. Okay, that a will be lambda minus 2 minus b 4, right? Okay, so there is 1 and a plus b, so lambda minus 2 plus 4 equal to 0, right? Okay, now let us simplify. So we have a lambda minus 6 and lambda plus 2 equal to 0, right? Okay, then what is the lambda? Lambda equal to positive 6, lambda equal to negative 2. Good. Now let's find eigenvectors. So for eigenvectors, so we have x. Yeah. Okay. Then that will be x of 1, x of 2. All right. So that will be, we are using lambda I minus a x, or we can just say using x equal to 0. Okay. The first of all, we are using 1 over lambda, which is 6. Okay, so there will be 6i, which is 1001 minus a in the case 2442. 2442. And we multiply x sub 1, x sub 2 equal to 0, 0. So I am following this form, right? Okay, so the first matrix we have 6, 0, 0, 6 minus 2, 4, 4, 2. And x sub 1, x sub 2 equal to 0, 0, right? Okay, now what do you get? 6 minus 2, which is 4. And the second one is negative 4. And the bottom has negative 4. Then last, we have a positive 4. Yeah. Then we are using x sub 1, x sub 2 equal to 0, 0. All right, so let us do decimals. So we using 4, negative 4, negative 4, positive 4, and 0, 0. We can omit this one in decimals. All right, then reduce the row echelon form. So what do we have? We have 1, negative 1, 0, 0, which is 0, 0. Okay, so this means x sub 1 here, x sub 2 here. So that is x sub 1, negative x sub 2 equal to 0. All right, look, we say that this is x sub 2 is free, right? So we can use any numbers, that means, right? Pick any number. All right. What do you want to pick for the x sub 2? So let x sub 2 equal to 1 is always easy, right? And x sub 1 equal to, then we can have 1, 2, right? All right. So that means we have x sub 1, x sub 2, which is the same as 1, 1, right? Okay. That's a 4 when lambda equal to 6. All right. How about for another lambda, which is negative 2, right? So we do same process for lambda equal to negative 2. So we have this form following. Copy. Okay, so there will be lambda equal to negative 2. And then identity is 1001 minus a. I don't remember. So 2442. 2442. Then we're using x sub 1, x sub 2 equal to 0, 0. Yeah? All right. Maybe I can have one more step. Yeah, it's okay. Negative 2, 0, 0, negative 2 minus 2, 4, 4, 2. And x sub 1, x sub 2 equal to 0, 0. All right, so where we have 0 there and negative 4 there. -4 there, and -2 minus 2, which is -4. Yeah. Okay, hold on 1 second. I made a mistake, right? So -2, -2, which is -4. And then x of 1, x of 2 equal to 0, 0. All right. Okay, let's using decimals. So decimals. So we are using -4, -4, -4, -4, 0, 0. We can omit in that case. Then reduce the row echelon form, find the solution, right? So reduce the row echelon form. So we have 1, 1, 0, 0. We have 0, 0. That means x of 1 here, x of 2 here. Yeah, x of 2 free again. X of 2 free. Okay, so let's rewrite this one. This means x of 1 plus x of 2 equal to 0, right? Okay, what do you want to pick for x of 1 or x of 2, right? So yeah, no, I said that wrong, right? So we have to pick the x of 2, right? To find the x of 1. So x of 2 is a free. Since x of 2 is a free, so x of 2, what do you want to pick? 1 as well, okay? So yeah, from the eigenvectors, we can have 0 eigenvectors, right? It can be 1, 0, but then not all zeros, yeah? Okay, so that's why we cannot pick the 0, yeah? So x of 2 equal to 1, then what's x of 1 will be? -1, very good. X of 1 equal to -1, right? All right, so we can rewrite this form, which is x of 1, x of 2 equal to -1, +1, right? Okay, so think general solution, we have y equal to c sub 1, y sub 1 plus c sub 2, y sub 2. But we talk about the vector, so we change that. C sub 1, y sub 1, c sub 2, y sub 2. Then this one has a form. C sub 1, what's the y sub 1? With a vector, so x sub 1, e to the lambda, the first one, t, right? And plus c sub 2, x sub 2, e to the lambda second one, t, yeah? Okay, now there will be c sub 1, we don't know, yeah? We're gonna find later on with the initial value problem, right? And x sub 1, we had the first with the lambda equal to 6, yeah? T. What's the eigenvectors in the case? There will be 1, 1. Yeah, so let me copy that. I am recording, right? Okay. So copy. There will be that. Copy. Okay, hold on 1 second. Let me move this one and then rearrange. Yeah. Make sense? So this is the one. Yeah. Okay, now the second one, right? So second one, c sub 2, vector x sub 2. So there will be this one, right? Yeah. Copy that. When eigenvalues is, I don't remember, 2? Yeah, -2. Yes? Okay, so -2. 2t, right? So just a notation. So this is the vector x of 2, right? So then we can say that this is a vector x of 2. Yeah, this is a vector x of 1. Just notation, right? Okay. Yeah, we done for the first part. So first part to say that find general solution. So we found this one, right? The pink. Now, what if we are given the initial value problem, right? So that is y over 0 with a vector. So vector y over 0 equal to 5 and -1, right? Okay, so second part, yeah, here we go. So I wrote down, and then I wrote down the general solution, right? General solution. Okay, so we have initial value, that, right? So we are using that, right? So when that means when t equal to 0, right? Means t equal to 0. Yeah, then we get the matrix 5 and -1. All right, so there will be, look, when t equal to 0, it's 1. Yeah, it's 1, it's 1. So we have c sub 1. Oh, let me write down. So y over 0 equal to 5 and -1, right? Equal to, I want to write down this one. Copy. And I want to write down this one because any 0 power for e function is the 1, right? Okay, so that means c sub 1, c sub 1 plus, no, not plus, negative c sub 2 equal to 5, right? And then c sub 1 plus c sub 2 equal to -1. Yeah. Then we want to find such a c sub 1 and c sub 2 constant, right? Okay. So same as before. All right. So c sub 1 minus c sub 2 equal to 5. C sub 1 plus c sub 2 equal to -1, right? So we get lazy using decimals. Yeah. Or we can find this one is easily, right? So c sub 2 equal to 0 and 2 c sub 1 equal to +4. That's c sub 1 equal to 2. Yeah. We can do that. Then plug in c sub 1 as 2. Then we can find the c sub 2. It's -3. Yeah. Okay. All right. So we can do that too. But that's not also, yeah, we can do that. It's up to you. Yeah. All right. So 1, -1, 5, 1, +1, -1. In that case, we cannot omit. Yeah. So we have to using that and reduce the row echelon form. So we have 1, 0, then 2, 0, 1, -3. Okay, that means C sub 1, C sub 2. So that is C sub 1 equal to 2. And that is C sub 2 equal to negative 3, right? Okay, then from the general solution, right? So we can substitute what is the C sub 1, what is the C sub 2 is, right? Copy. Oops. Okay, so C sub 1 is 2, 1, e to the 60 plus, but then C sub 2 is some negative 3, so we have negative 3, 1, negative 1, 1, e to the negative 2t. Yeah. Is it clear? Yeah. All right. So let me see. We can express this one. So one is 2e to the 60 and positive 3e to the negative 2t. Other one is 2e to the 60 and negative 3e to the negative 2, right? So because we knew that C sub 1, that is y sub 1, x sub, yeah, in general, yeah, C sub 1, y sub 1, right? C sub 2, y sub 2. Makes sense? Makes sense to you? All right, so where? Let me write down y sub 1 equal to 2e to the 6t plus 3e to the negative 2t, y sub 2 equal to 2e to the 6t minus 3e to the negative 2t. Yeah. All right. Okay, let us do one questions. All right, so we have solved differential equation with xy, and then we have initial value problem, right? And then find x over t, y over t, the element from the vectors, okay? All right, so we are going to writing out this one as like a matrix form, yeah? So there will be derivative respect to t, because we need to find x over t, y over t, right? And we have x and y there, so x, y, this form, right? Yeah. And then the constant coefficient, basically. So 59, 84, and negative 42, and negative 60. And then we are using xy there, right? Because they have xy, right? Okay. Same process. So we want to find eigen again. Form non lambda I minus a equal to 0, right? Okay, so we have determinant, oh, and lambda 1001 minus a, that is a. So we have 59, 84, negative 42, negative 60 equal to 0, right? Okay, so there will be determinant of lambda 0, 0, lambda minus rewriting negative 42, negative 60 equal to 0. Okay, so there will be inside we have lambda minus 59 and negative 84 and positive 42, right? And lambda plus 60, correct? Okay, now 2 by 2 determinant, we multiply this way. So there will be lambda minus 59 times lambda plus 60 minus multiplying negative 45 times 42, right? Equal to 0. Okay, so we do distribute. Let me fix a little bit here. So 60. And then we do distribute. So lambda squared. And then this is a negative 59 lambda. And positive. Sorry. And then I did. And then let us do that. Yeah. So lambda squared and positive 60 and negative 59 lambda and times, what do you get? It's negative 300, no, negative 3,540. And how much you have for this one? So 84 times 42, and then we have a negative, which is a positive. So I made a positive. So 3,528 equal to 0. Okay, so calculate. So we get lambda squared plus lambda minus 12 equal to 0. Okay, we can find the lambda. So factoring out. So we have lambda plus 4, lambda minus 3 equal to 0. Yeah, let's check that. Inside the positive 4 lambda, outer is a negative 3 lambda, which is a positive 1, right? So we get that. Check it out. Yeah. So lambda will be negative 4 and lambda is positive 3. Yeah. Okay. So maybe we can write down here. Oh, okay. Just copy. All right. So let's find eigenvectors. Eigenvectors. So, right? Okay. For lambda equal to negative 4. All right. So we had the form. So that is lambda I minus a, then x equal to 0, right? Okay, so lambda equal to negative 4 and I identity 1001 minus a. A is so this one, big number. Just copy. Okay, equal to, no, we have to have multiply by x of 1, x of 2 equal to 0, 0, right? All right, so then first matrix will be negative 4, 0, 0, negative 4 minus 59, 84, negative 42, negative 60, and x of 1, x of 2 equal to 0, 0. Yeah. Okay, now we have, oh, I need a little calculation help. So we have a negative 4 minus, you want me to write down? We don't need, right? So negative 4, negative 59, negative 63, and negative 84, right? And, and positive 42, and negative and positive 60, which is 56, yeah? Okay, then x sub 1, x sub 2 equal to 0, 0. Using Desmos tools, find the solution, right? So negative 63, negative 84, 42, 56, 0, 0. Then reduce the row echelon form. We have, so we have 1, 4 over 3, and 0, 0, 0, 0. So this means x of 1, x of 2. So that will be x sub 1 plus 4 over 3, x sub 2 equal to 0, right? Which one is a free? X sub 2 is a free, right? So means that we can pick any number for x sub 2, right? Free variable. Okay, what do you want to pick? Yeah, let x sub 2 equal to negative 3 over 4. You can pick anything, right? Okay, then x of 1 will be, it's a positive one, right? Okay, then we have the first vector when lambda equal to negative 4. So there will be x of 1, x of 2 equal to 1, negative 3 over 4. Yeah. Okay, good. Now, we have another random lambda. So positive 3, right? So we do same processing. Positive 3. Let me change that. Copy. Positive 3, right? Positive 3. Okay, so we have a 3, 1, 0, 0, 1 minus A. A. A is this one, right? Copy. And we have x of 1, x of 2 equal to 0, 0. Yeah. All right. So we have, maybe we can do 3 minus 59 and positive 42, and negative 84. 1 plus 60. No, 3. Yeah, 3. And x sub 1, x sub 2 equal to 0, 0. Yeah. All right. So there will be negative 56, negative 84, and positive 42, positive 63, and x sub 1, x sub 2 equal to 0, 0. Yeah, then there will be decimals. We have negative 56, negative 84, 42, 63, 0, 0. Let me put the microphone. What do you get? Reduce the row echelon form. So we have 1 and 3 over 2, 0, 0, 0, 0. So that is x sub 1, x sub 2 means that x sub 1 plus 3 over 2, x sub 2 equal to 0. And x sub 2 is also a free variable, right? So x sub 2 is the free. What do you want to pick? So let x sub 2 equal to negative 2/3. Then x sub 1 equal to 1. Yeah. Okay, then we have another vector, x sub 1, x sub 2, eigenvector, right? So we have 1, negative 2/3. Okay, so we are using, hold on one second, let me using the other. Okay, so I want to make everything. So I want to make just a vector u of t, then c sub 1. This is so far what we did, right? Like earlier, today, y equal to c sub 1, y sub 1 plus c sub 2, y sub 2. Then what was the y sub 1? Vector y sub 1, we had x sub 1, and then e to the lambda t, right? And y sub 2 also x sub 2 vector e to the lambda t. This is the first lambda, this is second lambda. Remember? We did that previous example, right? So we are going to summarizing like this one. Yeah. Okay. In that case, we are using two different variables, x and y. Okay, I'm gonna explain to you. All right, so we have c sub 1 and the vector x sub 1, right? So x sub 1 and e to the, hold on one second, e to the what? We had one is negative 4, other one is a positive 3, right? So when lambda equal to negative 4, we have this. Yeah. So this is x sub 1. Yeah. So let me copy this one. Copy. And in that case, and the first one, plus c sub 2, x sub 2, e to the lambda second one, t. Yeah. All right, so there will be x sub 2, right? I am using like a previous one notation. Yeah. Okay, then there will be c sub 1 and e to the lambda first one, 4t plus c sub 2. There will be 1, negative 2/3. Copy. And e to the second one, 3t, right? All right, now our goal is x over t, find. Look, our goal is by using initial value problem, we want to find x over t, y over t, right? So x over t, y over t come from here. So there will be x equal to, we rewrite this one. So there will be c sub 1 e to the negative, oh, we have a negative 4t, right? So negative 4t plus c sub 2 e to the 3t. Then y will be c sub 1, but then we have the coefficient is negative 3 over 4. Make sense? Negative 3 over 4 e to the negative 4t and minus 2/3 c sub 2 e to the negative 3t. Yeah, remember? I said that where earlier y sub 1 equal to this y sub 2, which is that. Yeah, well, I just changed the variable. This one is x, this is y, because your question, not your question, the question asks us what's the y over t, x over t, y over t. Yeah, make sense to you? So we initially start x and y, yeah? Yeah, just the notation. So this one is the same as y over t in the beginning, right? But then y, I'm not using y because it's the same y here. That's why. I just using vector u over t instead of y over t. Clear? Okay, now we need to use initial value problem, right? So so here we go. X over 0 equal to 11, y over 0 equal to negative 8. Yeah, so copy. Let me paste first. So there will be x over t, right? So x over t equal to y over t equal to, right? Then we're using initial value problem. So x of 0 equal to, when t equal to 0 is 1. So it's 11 given, and c sub 1 plus c sub 2, right? All right, now y over 0 equal to negative 8. Then we get negative 3 over 4. I'm missing c sub 1, right? So c sub 1 there. And minus 2/3 c sub 2. Yeah. Okay, once again, decimals. Easier, right? Yeah. 1, negative 3 over 4, and negative 2/3, and 11 and -8, finding the solution. So we will get reduce the row echelon form will be 1 0 0 1 and 8 and +3. Okay, so that will be 6 of 1, 6 of 1, 6 of 2. So there will be 6 of 1 equal to 8, 6 of 2 equal to +3. All right? Okay, then how do we use? We use here so x over t with 6 of 1 and 6 of 2. All right? Okay, so we have x over t. Let me copy. Copy. Mm, I'm checking. So, okay, so yeah, 6 of 1 x over t equal to 6 of 1, which is 8, e to the -4t plus 6 of 2, which is 3 e to the -3t, right? All right, so let me double check y over t. Okay, so y over t is just using that. So y over t, let me using. So we have a y over t. Copy that. And we have a system 1, which is 8, right? So let us do that. Equal to -3 over 4, system 1, which is 8, system 2, which is a +3, right? And e to the -4t minus 2/3, and e to the 3t, right? Okay, we simplify. So it's a -6 e to the -4t, and simplify. So we have a -2 e to the 3t. Make sense? Okay, so that is solution, right? So we found x over t, that, copy, and y over t is that. Make sense? So this is from vector u over t. We have x and y there, right? Okay. Now, let me explain to you this one, then we done. All right. So we have 3 different eigenvalues related graph here. So let's take a look this one. The first one, 2 negative eigenvalues. That means motion toward to origin. So everything toward to the origin. Yeah. In that case, it's 2 negative eigenvalues. So for example, we have lambda 1 equal to -3, which is negative. Lambda 2 is also -2, right? So in other words, we can say the terminology stable or sink to negative eigenvalues. The shape, the motion toward to the origin. Now, what if we have eigenvalues of a different sign? One is positive, one is negative, right? We call saddle. Yeah. And then the shape is lines are trajectory. So looks like this. Trajectory, 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 trajectory. Yeah. So for example, one is a positive 4 lambda, other lambda will be -1, different sign of eigenvalues. All right. Okay, now the last one, we have 2 positive eigenvalues, motion away from origin. So the first one, we had 2 negative eigenvalues, the motion toward to the origin, right? But then this one, 2 positive eigenvalues toward to from the origin, yeah? Away from the origin, yeah? Okay, so looks like that. Away from the origin. You may make a little bit clearer. So this one toward to the origin, yeah. And this one away from the origin. How about that? Yeah, away from the origin. So error, yeah. Okay. We called, this is terminology unstable or source. Yeah. And then this is 2 positive, lambda 1 equal to +1, other one is positive 3. Yeah. So it's okay. So very short about the graph and terminology. Okay. All right. Thank you for watching. Bye. We done. Yay. Okay. Thank you so much for your hard work and your effort. Good job. Bye.